We're now going to move on to our piecewise defined function. Now, a piecewise defined function is a function that has different definitions for different parts of the domain. As we saw earlier, the absolute value function is a piecewise defined function. Now, earlier we talked about how to split a piecewise defined function into an absolute value function into two pieces. So we're going to review the process by going through the steps. But if you don't quite understand the steps, I highly encourage you to go back to those previous videos. So the absolute value of x minus 1 over x plus 2 equals, we're going to break it up into positive x minus 1 over x plus 2 if x minus 1 is greater than or equal to 0, and negative x minus 1 over x plus 2 if x is minus 1 is less than 0. Now here, using the split point technique, our split point is 1, 1, x minus 1, positive, negative, it's 0 at that point, positive, 0, negative. So x being greater than or equal to 1. And here, a similar process, we'll see x is less than 1. So this is equal to the function x minus 1 over x plus 2 if x is greater than or equal to 1, and 1 minus x over x plus 2 if x is less than 1. Now, if we graph this, the function will look like the following. We're going to have a horizontal asymptote at minus 1. We're going to have a vertical asymptote at 2. We're going to have a root at 1. And then it's going to do this. And it'll have a horizontal asymptote here of 1. And this is at 1, 2, 3, 4, so on and so forth. And this part of the curve is a little bit steep. It's going to look like that. And we have our expression. Highly encourage you, take this, throw it on Desmos, and see what you get. Our next function is the root functions. The function f of x equals x to the 1 over n, which equals to the nth root x, is called a root function. Here, n is a positive integer. Now, the root function, there's two types of root function. We have our even roots and our odd roots. With our even roots, we talked about before that our natural domain is when x is greater than 0. So everything inside we have, this is equals x to the 1 over n, or the nth root of x. And here, this again, x equals 1 over n, or the nth root of x. But here, n is odd. When n is odd, there is no domain restriction. So here, domain restriction exists if n is even. So there's only a domain restriction if n is even. now we get our power functions. Now, our power functions are kind of like our polynomials, kind of like our roots, but not really, right? Let x be a real fixed number. Then f of x equals x to the a is called a power function. And here, a can be any real number. Now, if a is irrational, which we talked about irrational numbers before, then the power function is a limit. And we will not discuss this here. And depending on which course you discuss, you may or may not discuss the power function as being a limit. What it is it's the limit as q approaches a of x of q, where q is a rational number. But we're not going to discuss this here. You may discuss this in your future calculus courses, depending on how proof heavy the course is. Now, if a is a positive integer, then the power function is a polynomial with degree n. And if a is a negative integer, then the power function is a rational function. Now, if a equals 1 over n, where n is a negative integer, is n a positive integer, then the power function is a root function. And if a is a rational number, then the power function is a root function composed with either a polynomial or a rational function. We'll discuss this more with examples, and especially when we talk about composition. We'll discuss these properties. Now we're going to talk about how we can change functions or adjust functions. This is called transforming functions. Now, later we're going to talk about how we can put functions together. This is just dealing with a function itself. And when we have a function, there are 3 transformations we can apply to the functions. We have translations, stretches, and reflections. Now, if we consider g of x, we can apply 4 constants to this function. We can translate it using 4 different constants. A is a vertical stretch factor. B is a horizontal stretch factor of 1 over b. H is a horizontal shift factor of h units. And k is a vertical shift factor, k units. These represent our translations, and these represent our stretches / reflections. And this is something that should be reviewed for most people. And here what we're going to do is we're just going to give you some exercises to work through. And I really, really encourage you to draw the original function, apply your translation, and verify what you got using Desmos. This is a really good practice to go through, and this is a skill that you should practice and work on from high school.